Good morning. At 1 o'clock. It's morning somewhere, just for the record. Okay. Our objectives for this chapter, except it's just a section. The section is called Distance and Midpoint Formulas and also Circles. Okay. Our objectives are to find the distance between 2 points, find a midpoint of a line segment, write a standard form of a circle's equation, give the center and radius of a circle whose equation is in standard form, and convert the general form of a circle's equation to standard form. Okay? So, you ready? All right. Find the distance between 2 points. Do you know the distance formula? Please don't all speak at once. Okay. D equals the square root x2 minus x1 squared plus y2 minus y1 squared. That's the distance formula. Do you need any examples of using the distance formula? Not really, right? That's something you did a lot in geometry. Okay. I guess really the hardest part, quote unquote, hardest part of using the distance formula is remembering if you have 1, 4, and 7, 5 that you're trying to find the distance between. Some people just forget what to do, so I would recommend that you label everything if you're having any trouble at all so that you remember what goes where. Okay? That's really it. Like for real. Okay? For reals. For reals. What about the midpoint formula? Do you know the midpoint formula off the top of your head? If it makes you feel any better, I don't either. I just know how to do it. Okay? So I'm looking when I'm writing this down. x1 sub 1 plus x sub 2 over 2, comma, y sub 1 plus y sub 2 over 2. So you're finding the sum of the x's and taking it in half, the sum of the y's and taking it in half. Okay? Except that kind of makes sense. If you're trying to find the middle of 2 points, you would add each part together and divide it by 2, add each part together, divide it by 2. Okay? Again, any questions about this? Same kind of thing. If you're having trouble, label your points so you know what goes where. Okay? So that takes care of our first two objectives, finding the distance between 2 points and finding the midpoint of a line segment. Again, I didn't show this to you, but I will be happy to if you would like to see them. No? Okay. Third objective, write the standard form of a circle's equation. Okay? So standard form, in this book, standard form is what we called in Algebra 2 vertex form. Okay? So x minus h squared plus y minus k squared equals r squared. This is what the book calls standard form. Like I said, we're used to calling it vertex form because that's what we called it in Algebra 2. But this is standard form. So if I say to you, the center of the circle is at the origin and it has a radius of 6. Well, center of the circle is at the origin and has a radius of 6. This right here is h, and that's k. So x minus h is just x, and that's squared. And y minus 0, k, is just y, and that's squared. And r is 6, and that's squared. So that's the equation. Now it doesn't get a whole lot harder. 1, negative 4 with a radius of 5. X minus 1 squared plus y minus a negative 4 squared equals 25. I don't even really know how to make it harder unless I give you just bigger numbers. Okay? The quote-unquote hardest part about this is remembering that if it's minus 4, y minus a negative 4 is going to be y plus 4. Okay? But honestly, the only way I can make this harder is by giving you bigger numbers. Okay? So we took care of the distance formula. We took care of midpoint. We took care of number 3, write a standard form of a circle's equation. Okay? Now, number 4 is pretty much backwards of number 3. It says, give the center and radius of a circle whose equation is in standard form. So if I give you this, x plus 2 squared plus y minus 3 squared equals 4, can you tell me the center? Negative 2, 3, because it's x minus something, so that's got to be negative 2. X minus something, that's 3. And what's the radius? Close. Yeah, because it's the square root of that number, right? Again, the only way I can make this harder is by giving you bigger numbers. Or by giving you, like, making this, here, I can make it a little bit harder. Y minus 5 squared, I said y, but I meant x. I'm sorry. X minus 5 squared plus y minus 1 squared equals 7. Ooh, what's the center? 5, 1. What's the radius? Square root of 7. That's as hard as I can make it. Okay? Now, you could take this to a decimal if you needed to. Like if it says graph it, go graph it, you would have to make that into a decimal to know exactly how far to go out. Yes, sir? This one right here? Yeah. Because right here, it gives you the center and the radius, and it just asks for the standard form of a circle's equation. Yeah. Okay. Now, the next one, it says convert the general form to standard form. Okay. That's the only one that I think you might have trouble with, only because you've got to remember how to complete the square. So I'd like to walk you through at least one of those, if not more than one, to remind you about completing the square. Okay? So we're working on objective number 5 right now, converting the general form of a circle's equation to a standard form. So here's what I want you to remember. Standard form is x minus h squared plus y minus k squared equals r squared. Okay? General form is x squared plus y squared plus dx plus ey plus f equals 0. Now, please keep in mind these were different letters than we used in Algebra 2. They're not wrong, they're just different. Okay? And this also, I always want you to realize that D, E, and F are real numbers. Okay? In order to convert general form to standard form, we have to do that by completing the square. Okay? So here's an example. X squared plus y squared plus 4x minus 6y minus 23 equals 0. Okay? X squared plus y squared plus 4x minus 6y minus 23 equals 0. Got it? First thing we want to do is rewrite this equation. I want to group all my like terms together. Okay? So I want to write my x squared with my x, and I want to leave myself some space. And then I want my y squared with my y, leave myself some space, and then I want to go ahead and add 23 to both sides. Or whatever number is right there, add it or subtract it, whatever the constant is, get it away to the other side. Okay? Now I just want to look at my x terms right here. If I'm just looking at my x terms, I have to complete the square. I need to add something right here to make this a perfect square trinomial. And just reminding you how to do that, take this middle term, the term with just the x, take the coefficient of that number, divide it by 2, and square it. So 4 divided by 2 is 2, and 2 squared is 4. So I add 4. But if I add 4 here, I also have to add 4 on the other side. Very good. Seems like a couple of you remember at least a little bit of this. Yes? Okay, good. Now I just want to look at the y's. Okay? Take that middle term, that y term, divide it by 2. So 6 divided by 2 squared, 9, right? Now, some of you wanted to do the negative 6, and that's totally fine, okay? Because negative 6 divided by 2 is 3, negative 3, and then negative 3 squared is 9. So this is always going to be adding, right? Because anytime I square something, it's going to be positive. So you can do the 6 or the negative 6. It won't matter. Just to remind you about that, okay? But if I add 9 here, I have to add 9 over here. Okay, so far? All right. Now I want to take this trinomial and write it as its perfect square binomial. So it looks like this. Okay, what's the term that's going to go right here? Well, it's either half of this or the square root of that. 2. So I want to take this one, write it as its perfect square binomial. It's either half of this or the square root of that. This time that negative matters, doesn't it? So minus 3 equals what? 36. Now we're done, right? What's the center? Center is negative 2, 3. And what is the radius? 6. Do we need to do another one of those? Please don't? Okay, gotcha. So your objectives were for today were find the distance between 2 points. You didn't want any examples of that. Find the midpoint of a line segment. You didn't want any examples of that. Write the standard form of a circle's equation. I showed you that. Give the center and radius of a circle whose equation is in standard form, which is like backwards of number 3. And then convert the general form of a circle's equation to standard form. Any questions? All right. Peace.